So welcome to our July potpourri. We have a slight change in our lineup today. Shaquille couldn't make it. So we've got Harry, who our junior, he's raising his hand, our junior member is going to be presenting. So we're looking forward to Harry presenting today. We'll start off with my presentation, and then we'll move on to Harry. And we have two other presentations after break as well. So as you know, we love to travel, my family and I. So I try to do at least one presentation a year on my travel story and related back to astronomy. So this is one of them. It's a bit early in the season. Normally I come out in September. So it's a bit early in the season. So with that said, it's July, and July is what? What's the significance of July other than being summer? Canada Day. So we'll stay in Canada for our trip today, and we're going to go to Newfoundland. Anybody been to Newfoundland before? Oh, a few of you. I would love to hear your impressions after the talk for sure. So our journey started just before Canada Day. We spent about 8 days. So my husband, my two daughters, the four of us went to Newfoundland. We flew from Toronto and flew into Gander. This is our second trip to Newfoundland, and last trip was about 18 years ago. But this time it was from a very different perspective. We'd only been to St. John's before. This time we touched Gander, and we touched Gander on purpose. The 2.5-hour flight, easy peasy, super easy flight. I'm going to be giving some kind of travel tourist tips along the way too, in case you decide to go. The reason we went into Gander is for two reasons. One of them is because I'm a big aviation buff as well, other than being an astronomy buff. So for me, airplanes also, it really excites me. And Gander has a long aviation history. In fact, the Gander Airport was the largest airport in North America many years ago, and was the hub between North America and Europe. That's where the flights used to land to refuel. If anybody has stories about Gander, definitely feel free to share, but I'll share a few stories today. So we flew into Gander, and what's up there is the map. So once we flew into Gander, we rented a car, then we went up to Twillingate. So I said there were two reasons why we went. One of the reasons was because of the aviation side. The other one was because it's Iceberg Alley. And I have never, until this trip, ever seen an iceberg in my entire life. And that was one of my bucket list items to do. Everybody told me, I spoke to a few people in Newfoundland, as I was planning the trip, and they go, you're coming at the end of June, early July. Don't get your hopes up high. You really need to be here, May timeframe. But anyways, let's see where we went. So from Gander, we drove to Twillingate, about an hour and a half. We got an Airbnb. And then from there, we spent a couple of days there. Then we went up to Bonavista. And from Bonavista, then we went to St. John's. It's about 800 kilometers of driving in fairly windy roads. They're not super hilly like the West Coast, but there are hills and ups and downs, but the scenery is gorgeous, and cell phones don't really work. So we had no cell phone service pretty much throughout, but it was nice to be disconnected and really relax. The cell phone service was very spotty. And we are with Bell, so if you're with Rogers, maybe you have better luck, I'm not sure. So that was kind of our trip, and that's why I have that slide up there. With that, let's get into it. So welcome to Newfoundland. It's July, it's Canada Day. Let's celebrate Canada. And Newfoundland is the easternmost province of Canada. And it's actually Newfoundland Labrador, in fact. It's 29,000 kilometers of absolute gorgeous coastline. And the population is about 530,000, so less than GTA. The entire province is less than that of GTA. Atlantic puffin is the official bird, and we're going to get into that in a few slides. And I have some dark sky sites to share with you. So if you're making a trip out there, you may want to make a note of those dark sites when that slide comes up. These pictures that you see are all mine, except where I've given credit. There are a couple that are not mine, but I've credited those. But those pictures are all mine. So you can see notice the sky as you kind of go through, as you see these pictures, how blue the sky is and how the blue the sky was not when it came to observing. Now, we had about 3.5 hours of astronomical night. So that was it. So the sun would set around like really dark around midnight. Even though the sun really set around 9:50, 9:30, the real dark time was around midnight. By 3 o'clock, the sun was already rising again. So even then, what would happen is the days would start off just absolutely beautiful, bright, get all excited. By about 9 o'clock, it kind of knew the sun was going to set, the clouds would roll in. So those were, I guess that's just part of being on the East Coast. All right, from Earth, we go to Mars. So we go to Mars specifically because there are 3 craters on Mars that are named after Newfoundland towns, including Gander. So this picture actually is the credit of the Planetary Nomenclature Society. So in 1991, the International Astronomical Union Working Group for the Planetary System Nomenclature recognized Gander as pioneer aviation city. Remember, I mentioned that a few minutes ago. And it named one of the craters as Gander up on Mars. And it's located near the Jezero crater, which is, of course, where the rovers are. So, and there's 3 of them. So the Gander is one of them, Nain, and then you've got Nutak. So those are the 3 craters on Mars that are named after the Newfoundland Labrador towns. Gander. So on the, anybody seen Come From Away? The musical? A few of us, right? We know, if, for those who don't know, Come From Away is based on the story about how the people of Gander really opened up their hearts and how homes and provided food and shelter for about 5 days to the plain, we call it plain people, the plain people who landed during 9/11 when all of North American airspace got shut down and the planes had to land at the nearest airport. The Gander took in about 38 airplanes, and they had, and there are lots of stats around this, but you'll see this blue piano it's a big musical, it's a Broadway hit, it's in Toronto. If you haven't seen it, go see it. I've seen it twice, it's a lot of fun. It was actually locally made in Sheridan. The Sheridan College is the one that there were people in there who actually put this musical together, and now it's a huge hit across North America. So this piano is at the airport. So if you are there, if you have a few minutes, you can always sit down to play. And this was donated by the Come From Away musical people. In the center where you see those blue chairs, that's the airport. It's a 1-room airport. There's, I think, a room at the back for arrivals, etc. But there was a big US aircraft carrier standing in there. Huge aerodrome. We were the only, that plane up there was ours. We took the assisted aircraft Rouge. I just took from the, so they let you off. You walk on the aerodrome, where the planes land, and in you go. When we got off, going from Toronto, it was so hot, it was so cold in Gander. So there was a bit of a shock. Another interesting fact is that if you'll see in the middle picture where the chairs are, there are 2 staircases leading up. That's an aviation museum. And it's a really interesting place. I didn't think much of it, but when you could actually spend at least 2 hours reading this great history. And parts, and I have a couple of pictures in there, but apparently the Concorde was tested as an aircraft in Gander. So that was an interesting fact. And because Gander had given refuge to so many people, New York City has presented Gander with a structure from the fallen buildings. And you'll see it on the bottom, I guess, bottom where the brown picture is, bottom right. So that's it on display as well. And there are many, many celebrities who passed through Gander over the years, given that it was such a major hub, including Albert Einstein and including Queen Elizabeth. And in fact, there's a signature of her, if you're royalists, there's a signature of her and Prince Philip on display. It's one of the rare ones that is publicly available for you to see. And there's so much more you could read. I just didn't have enough time today to kind of cover it all, but those are the highlights. And below you'll see like Arnold Schwarzenegger and Muhammad Ali, etc., pass through this airport. So that was kind of fun. And then from there, we picked up our car. There's another museum there, but we couldn't get to it. North Atlantic Aviation Museum. It was getting closer to the end of the day, and we had to get going to Twillingate. I really wanted to see the icebergs before they melted because I was watching the Facebook, and everybody told me they're going to melt. So I'm like, let's get on. We'll get to the Aviation Museum later. We never did, but the point is, as soon as we drove, and I'm watching this Facebook page, and people are posting, and I'm like, we need to find where this is. And so Google, remember I said to you, the cell phones don't work. So we had already downloaded everything, we had planned everything. So we got to this place, and I'm looking around, there's no iceberg, there's water and houses, water, houses. My husband makes a turn, and at this, from the side of my eye, I'm like, stop. He says, what? Iceberg. This massive thing was behind a house in somebody's front yard. And that is the picture on the very left, the little iceberg. And that was literally somebody's in the town of Twillingate in front of somebody's house. So that was kind of cool to see. So we were all excited, taking pictures, etc. And then the next day we had a tour booked on a boat. And so we got on this boat, and they made, and there was, by the way, there's a second iceberg in town that was almost melted off, but I don't have pictures of it here, but that was also cool to see. The point is, we got on this boat, and it was supposed to be a 2-hour ride. We turned it into a 4-hour round trip. Why? Because the iceberg was so far away, 8 nautical miles or almost 20 kilometers of a boat. So an hour and a half to get there. So those pictures that I sent on our group's IO, and which are shown here, the middle and the other one, that's this massive iceberg. This is Iceberg Alley. Where did these icebergs come from? Greenland. So these icebergs have spent 4 to 6 years traveling to Newfoundland, and they started off with, they're about 12,000 years old. They started with this one snowflake, and these are massive. These are the remnants of what was there. People showed me pictures. They were larger than towns, apparently 2 kilometers. In May, there was this iceberg. You'd have to go to 2 kilometers to go around it. It was massive. So anyways, I was happy to see it, and it was absolutely gorgeous. And I'm not just going to show you pictures. I'm going to show you a bit of a video so you can take a quick look at it from a video standpoint. If I can get to it. So this is something we took from the boat. And I don't know if you can hear any audio, but we'll try. Great dark skies, and I'll show you some pictures later. The one thing I want to call out on this slide over here is this place called Brimstone Head. The Brimstone Head, for any flat earthers that you might know, this is one of the 4 corners of planet Earth. And so Brimstone Head is where it's one of the corners, and there's 3 other ones. I was trying to find them. I ran out of time. But the point is that this is one of the 4 corners of Earth. And Fogo Island, there's a really, I was watching some YouTube videos. It's a very interesting place. Somebody from Silicon Valley is trying to redevelop that town. And she spent a lot of money. And if you have $5,000 a night, you can get an all-inclusive on Fogo Island with food and everything included. And every single item made in that hotel is made by the local fishermen. So it's really very interesting. Okay, and my friend puffins. I love these cuties. So this is Elliston and Bonaventure, and we stayed at an Airbnb in a place called Port Rexton, and this is 30 minutes away, easy drive. And the reason it's very interesting to go to Elliston, this is probably the only place that you can get a few feet from the puffins. So the Atlantic puffins are usually on an ecological island that humans can't go into unless you're a marine biologist or something like that. This is the only place where you can, as a civilian, get very, very close to it. Of course, you're not supposed to interact with them, etc. So these are one of the breeding grounds. But these pictures were taken by my Sea Star S30. I had taken the Sea Star S30 and I found a daylight use for it because I wasn't able to use it at nighttime. So, so I just thought, the close-up pictures that this guy took, I'm like, I'm gonna take it on my next trip if I can. One thing there though is there are security checks along the way at the airport. Yeah, I think it's 250. I'm pretty sure it is. And somebody else can correct me on that one. But yeah, this has the landscape mode on it. And to get close to these guys, I think that was so cute. All right, so then from there, we went on to St. John's. And of course, we arrived June 30th and July 1st, we wanted to celebrate Canada Day at sunrise. So we got up at 5:30 in the morning and went to the official sunrise celebration and look at the weather. It was all foggy. It was up on Signal Hill. We stayed in Airbnb on towards Signal Hill. And it was a very nice ceremony, and we got really nice cupcakes afterward at 6 in the morning. But that was a really nice done and a unique experience in its own way. And on the other side, you'll see the Signal Hill, and this, of course, has its own historical significance. Marconi sent the first wireless communication cross-Atlantic from North America to Europe. And what he didn't know at the time is the Earth's ionosphere was actually helping him out. And, do read about it. It's a very, very interesting experiment that they ran. They were successful, but that's Signal Hill, and it's a fun place to go. On Signal Hill, there's a museum called Johnson Geo Center. It was raining that day. That was, by the way, the first day we got rain was in St. John. Otherwise, there had been blue skies. I don't know if you were noticing the pictures, or blue skies throughout our trip, except in St. John. So we said, it's a rainy day. What do we do? Across the street with Johnson Geo Center. I didn't know what to expect. I thought it would be very, it'll be interesting, but I didn't realize I was going to see RASC stuff in there. And for anybody who's been to St. John's or has seen this, it was a pleasant surprise to see the RASC, the St. John's RASC being called out so much. And specifically, Dora Russell and these are pictures from within the Johnson Geo Center. So these are plaques. So Dora Russell, of course, was an author and journalist, and she was the president of the St. John's RASC, and wrote a weekly column called All About Stars. And then Ruth Northcott was associated with the Dunlop Observatory. She was the president of the Toronto Centre and the editor of the RASC Journal. And that telescope at the bottom is actually Ruth Northcott's, which was eventually donated to St. John's RASC, and then it has now come to this museum. So there's a lot of RASC history that was covered in this museum. And that kind of goes on a bit. So you'll also notice the stellar connection. So they were on loop, they were playing things, events that were happening with the St. John's Center. They were showing pictures taken by members like us. So St. John's RASC was really featured. And by the way, this Johnson Geo Center is part of the Memorial University. So it's really nice to be supporting with your small fee this university if you go visit. And we also noticed that there was information provided on the Labrador crater, which acts as an experimentation for the moon. So, and I think there was a talk here at one point that we had a speaker who spoke about this. So that was really interesting. So University of Western Ontario and Memorial University do some experiments. So that was interesting too. And this is just such a nice place. Cape Spear is the easternmost point of North America. And next up is Ireland. So this is really cool to see. It's got a plaque up there, and you can spend the whole day just admiring the beauty of the place. And there's so many whales at this time of the year. You can watch them from shore. Really fun place. We spent about 4 hours. Going back to my dark sky. So these are my pictures from the Sea Star. It didn't do a bad job. So in Port Rexton, where we stopped before we saw the puffins, that one night, the sky was clear. I was watching. I'm like, is it going to clear? Is it going to clear? Yeah, cleared out. Sky was ablaze with stars. You could see the Milky Way with naked eye. And then, then I was able to just take, these are like only 15, 20-minute runs on the sea star. I got a Whale Nebula out of it. I got the Eastern, I got the Western, Cocoon, and Omega. I don't see these things from Oakville because they are very difficult targets to get, even with the sea star. It takes a long time for you to image. And by the way, the middle one is none of these are processed, right? So these, look at the stars. I mean, I was just so lucky that one night I'm happy that I got these pictures. And then
social creature. They're inquisitive, they're curious, 10 o'clock. There he is. Oh yeah, what a look. Awesome.
There was a video here. So anybody know about Screechton? Yeah, okay. Three. Oh, you're brave. You're brave. You're brave. You're brave. Okay, I'm gonna try to play it. I'll try to play this. This video we have to play for you.
And don't forget, the last person to kiss the fish kissed everybody else.
And then from there, that's it for me for now. Thank you. Okay, we're going to have to go on to our next speaker is Hari Amathun, who's going to speak about measuring distances to celestial objects.
Okay, so hi everyone. My name is Hari. I'm a IB student in Mississauga, grade 10. This will be my first ever potpourri. So I just wanted to try it because I've been a member here for around 5 months. I just wanted to try a potpourri and then I might try some more later on in the summer. So I started to get into astronomy during the pandemic because I had nothing much to do. And then yeah, I've always been interested in astronomy. And then around 5 months ago, I joined this RSC as a member. So this will be my first potpourri, and yeah, we'll see how it goes. Yeah, I was supposed to present it on May 9th, then I couldn't, so here we are. So this potpourri is basically about measuring distances to celestial objects like planets and the moon and the sun, using nothing but simple experiments that you might even be able to try at home. So before we start, here are some things to note. Number one, no planet or moon is a perfect sphere, although the sun is. So the sun is actually the best example of a perfect sphere in nature. So the sun is 99.9997% perfect sphere. So to date, that's the most perfect sphere that humans have ever found. So, but that's not the case for every single planet. Some planets are notably elliptical. Number two, some planets' orbits are less circular than others. And a good example would be Mercury. So Mercury's orbit is very elliptical. And the reasons for that is because of the gravitational pull of other planets. And a little bit of it is also because of the bend of space-time. So all planets orbit the sun on approximately the same plane or elliptic as the moon orbits Earth. This is generally true, even though there are slight deviations. And this means that all planets, the sun and the moon, appear to lie on the same line as viewed from Earth. So you can see everything on the same line. That line is basically called the zodiac. So you wouldn't see a planet anywhere outside of Sagittarius, Virgo, Libra, all these constellations. And lastly, the moon and sun don't lie perfectly on the ecliptic. They instead appear to slightly deviate away from the ecliptic as viewed from Earth. So obviously nothing in nature is perfect, the universe isn't perfect, so there will be a slight deviation. So we're going to assume that that isn't the case since it's close enough. So we need that for the experiment to work. So the first step will be to calculate the average distance between Venus and Sun relative to the average distance between Earth and Sun, which is known as an astronomical unit or AU. So yeah, one astronomical unit is the average Earth-Sun distance. The Earth-Sun distance changes over time because Earth has an apogee and a perigee in its orbit. Earth's orbit is also elliptical, but this is basically the average. So Venus is an interior planet, so that means its orbit is inside of Earth's. So it'll experience phases like first quarter crescent, last quarter crescent, and such. So this is an interesting experiment we can try when Venus is at its quarter phase. So here we can see this most recently happened on January 12th. Venus was at its quarter phase, its first quarter phase. So this would be like the view on a telescope over there. And as you can see on the diagram, the angle between Earth and Venus and Sun forms an exact right angle when Venus is at a first quarter, last quarter phase. And that would be the diagram. So Earth to Sun is a 1 AU, 1 astronomical unit. And that's Earth to Venus, Venus, Sun. So what we can do if this is a case is here's what we can do. We can measure we can get the coordinates of Venus and Sun in the sky. So we have the Sun at sunset, so altitude 0, and the azimuth 240. You can check that using a compass, since that's azimuth. And then we have Venus at altitude 34 and azimuth 206. Again, you can check these coordinates using any app like Stellarium, Sky Safari, or anything. But there's also like instruments such to like measure the distance. For example, there's something called a sextant, which is basically it's something the ancient Greeks used to measure altitude in the sky. So we can make a triangle, right angle triangle like this. We know that Venus is 34 degrees above the ground. Venus is 34 degrees away from the sun in terms of compass heading. So we can calculate that distance between Venus and sun is 48.1 degrees, approximately. So that would mean that we can do some simple math here, some simple trig. We can find out that the Venus to sun distance is approximately 0.74 astronomical units, according to these calculations. So we'll get back to the exact value later on. We'll compare it in the end. So as you can see in the diagram, that angle between the Sun, Earth, Venus would be approximately 48 degrees. The angle between Earth, Venus, Sun would be a right angle, according to the calculations. This was, I did this on January 12th, 2025, around sunset, because that was the exact time the Venus was at the quarter phase. Next, we're going to do the exact same thing, but now for Mercury, which is the other interior planet. Venus and Mercury are both interior planets, right? So again, 1 AU is equal to the average Earth sun distance. This happened more recently on April 23rd, 2025. Mercury was at its quarter phase again. This would have been the view in a telescope. So as you can see, the diagram here, from Earth to Mercury and Mercury to Sun is a right angle triangle. And we can do the exact same calculations we did for Venus over here. So we have the sun at sunrise, altitude 0, compass heading 71. Mercury, altitude 8, compass 98. So again, you can measure this using like Sky Safari or Stellarium or anything. You can also use like a compass and such. So doing the same math that we did before, we find that, Sun and Mercury are 27 degrees apart with compass heading, and Mercury is 8 degrees above the ground, above the horizon. So we find that Mercury and the Sun are approximately 28.2 degrees separated apart in the sky. So again, we can calculate that the Mercury to Sun distance is approximately 0.47 astronomical units in accordance with these calculations on April 23rd. So since Mercury's orbit is elliptical, the angle actually varies slightly from 18 degrees to 28 degrees. That's like a huge variance. So on this particular day, I measured it to be 28.2 degrees. However, it might not be the same for you. It might not be the same on every day. It certainly won't. Because and it certainly won't be the same in the morning and evening. So yeah. So next experiment is calculating the Earth's circumference and radius using the Eratosthenes method. So Eratosthenes was an ancient Greek philosopher. He was famous for many things, like the Caesar of Eratosthenes and everything. He was mainly a mathematician, but he was also an astronomer. So he was famous for calculating the diameter and circumference radius, the measurements of Earth, using nothing but a simple experiment. So he used two cities called Alexandria and Syene. They're both in Egypt along the Nile River. So they were both calculated to be around 800 kilometers apart. So by pure coincidence, it happened that at Syene, sign was directly on the Tropic of Cancer, which meant that on June 21st or June 22nd, the sun would be directly overhead at sign. So there was a well at sign, a groundwater well, and the sun would shine directly to the bottom of the well without illuminating the sides on June 21st only. Because again, sign was on the Tropic of Cancer. So he calculated the angle to be 7.2 degrees at a different city, Alexandria, where he placed a stick on the ground and he observed the sun shadow on the exact same day, June 21st, the summer solstice. So he calculated the angle between the shadow of the stick and the stick itself to be 7.2 degrees. Using that and the fact that the distance between Alexandria and Syene is 800 kilometers, he again did some simple math. So here's a diagram. It's a Z pattern. So it shows that if the angle between the sun and the sun shadow and the stick is 7.2 degrees in Alexandria, then the angle between the stick and Alexandria and the Earth's center and the well in Syene would be 7.2 degrees as well. So again, simple math. 360 degrees in a circle, Earth is a circle, divide by 7.250. 800 times 50 is 40,000, since Alexandria and Syene are 800 kilometers apart. So we get that the circumference of the Earth is 40,000 kilometers. That's the value that he got. And that value is actually very, very close to the actual value. It's 40,075 kilometers, so just 75 kilometers off. So using simple math, we get that the radius of Earth is 6,366 kilometers. Again, this is very close to the true value. And yeah, using that, we can calculate diameter as well. So this over here, this is calculating the average Earth-Moon distance. This is a bit harder experiment, like takes a bit more time. So yeah. Here's another diagram between the center of the Earth, center of the Moon, and a point on the Earth's surface, such that there's a right angle triangle formed between the center of the Earth, center of the Moon, and the point on Earth's surface. So if you do the measurements, radius of Earth is 6,366 kilometers, as we discussed previously. So if there are two people standing there, person A, person B, and you have the distance between them to be 9,900 kilometers, you can find out that the angle between them is 89.1 degrees, to be very precise. So person B has to be standing on the sublunar point, which means the moon will be directly overhead for them. It's known as the sublunar point. For person A, the moon will obviously be directly on the horizon. So it'll be either moonrise or moonset for this person. They will be not that far away from the North Pole, since this is 9,900 kilometers and the radius isn't that far away. So this is a simple diagram here, South Pole, North Pole. So if we continue, yeah, person A, person B must be around 9,900 kilometers apart. Person A will not be too far from the North Pole. Person B will be at the sublunar point, which means for them, the moon will be directly above them, like up there. For person A, it'll be moonrise or moonset, so moon will be at the horizon. So you get this will be the point of view for person A. You see the moon is at the horizon, and for person B, this will be the point of view. So the moon is directly in the center of the sky. So using this information, we can find out that the circumference of Earth, we know that the circumference of Earth is 40,000 kilometers, as we discussed previously. We can divide 40,000 by 9,900, which is the distance between person A and person B, which can be measured using various different methods. So we get 4.04 divided by 360, amount of degrees in a circle. We get 89.1, which again is the value here, the angle between person A, person B, and the Earth's center. Using that, we do some math here, and we get some math. Might not understand it, but the main takeaway is that we get that the average Earth-Moon distance is approximately 398,900 kilometers, which is again not that far off from the real value, but we'll discuss that in the end. So yeah, this again this will change over time since again the moon's orbit is also elliptical. It has apogee and perigee, so sometimes this goes over 400,000 kilometers. But yeah, we'll see that later. This is a final experiment calculating Earth-Sun distance or one astronomical unit with using all the information that we've had so far. So we've been discussing astronomical unit, AU, right? Now we're going to find out how many kilometers an AU is on average. So again, here's a diagram. We have the moon at first or last quarter phase, doesn't matter, any quarter phase. This is what the moon would look like. This happens like twice every month. We have the Earth here and the moon here and the sun here. Obviously, when you're looking at it at a quarter phase, there will be a right angle triangle formed here. We have the distance that we calculated before, which is 399,100 kilometers. That's the distance, average distance between Earth to moon. Then we have the Earth-Sun distance, which we will be calculating using this. Again, some simple math here. Simple math. So average Earth-Sun distance would be 152,455,100 kilometers, using nothing but the calculations that we got from the previous experiments. And again, this is not that far off from the actual value. And again, this will also change over time since, again, the Earth's orbit is elliptical. So yeah, we have the angle here of 89.85 degrees, which is very close to 90 degrees. Because the moon and Earth are very, very close together compared to the Earth and sun. So this angle over here will be very close to 90 degrees. It's almost as if there's a triangle without this vertex here. So it would be like this. The sun is very, very far away. So yeah, we get the distance to be 152 million kilometers for one AU. And so putting it all together, we have Mercury sun distance to be 0.47 astronomical units. We know that one AU is the average distance between Earth to sun. So yeah, average Mercury sun distance would be around 71,649,200 kilometers, which is not that far off again from the real value. Same thing for Venus, exact same steps. We got 112,809,400 kilometers using the exact same steps. So yeah, these are the results summarized in a table from all the experiments. So again, we have the Earth's circumference as a 40,000 kilometers. The currently accepted true value is between 40,007 to 40,075 kilometers. So the percent error is less than 0.19%, which is pretty good for like doing this with no technology, essentially, no tools. We also have the astronomical unit, AU, or the average Earth-Sun distance. We calculated 152 million, this number here. Average value is around this, approximately, because it changes throughout the year. So again, percent error of about 1.63, which again is pretty good. We have an average Earth-Moon distance of, again, what we calculated, 398,900 kilometers. The currently accepted true value would be 384,400 kilometers. The source is Royal Museums, Greenwich in England. And yeah, again, percent error is 3.77, still pretty good. Now the planet measurements, the planet experiments, this is where we had like the highest percent error. That's mainly because Mercury and Venus have elliptical orbits. They're the planets, I think, with the most elliptical orbits. So you're gonna have a higher percent error. If you decide to try this when Venus is in the morning, for example, you might get a different result than when you see Venus in the evening. Same for Mercury. It really depends on like when you observe it, when you try this experiment, what time of year. So average Venus sun distance, 112 million kilometers or 0.74 astronomical units. The actual value is around 108 million kilometers or 0.72 astronomical units. So percent error of 4.45%, still pretty good. Now for this experiment, we had a higher percent error because again, Mercury's orbit is very elliptical. We got 71,649,200 kilometers or 0.47 astronomical units. This will obviously change a lot. So currently accepted average value is around 58,000 kilometers, or exactly 0.4 astronomical units, which is again a 23% error. That's a percent error. And yeah, this is how I calculate a percent error. It's the measured value minus the actual value. Divide that by actual value times 100 to get the percent. And so these experiments, ideally, you could try this for yourself just to see if you get like, same results. And yeah, same results. Because the ancient Greeks, the ancient Romans, they did these kinds of calculations without any technology whatsoever. And especially Eratosthenes, he did all this. He got a value that's obviously very accurate. You can see percent error of just 0.19% for Eratosthenes. So yeah, you can definitely try this and you might get the same results. And yeah, that's it. Yeah, I didn't take into account like the atmosphere, but I guess that would certainly be a factor. You can go up to higher altitude because there's less atmosphere between you and the planet you're observing. But yeah, I thought that would be like a minimal factor. So maybe that's the reason for the percent error. So he calculated using states, which is basically like a long step. He calculated 565,000. So I just did the conversion and put it up as 800 kilometers.
But
Yeah.
it's interesting. Oh, he actually had to go out and have someone take that measurement for him.
Yes.
What's the-
Like if you miss a couple of steps, like every here and then, it would be off. So I got the idea from the website of theoretical physicist Matt Strassler. I was reading his website, and that's where I got the idea. But yeah, I'll check out like the turnstile YouTube. Okay, I just found it online on Stellarium, but yeah, you could do it visually. You could like, if you see that Mercury is like a crescent, you could keep observing every night until you see that like one night it's perfectly the line of illumination is perfectly down the middle. You could that depends on your eyesight, so yeah, you could do that as well.
So, hello everyone. This is my presentation on the space shuttle. I believe it's one of NASA's best programs aside from Apollo. So let's begin. So let me take you back. The year it's the late 1960s. The war, the competition between the Soviet Union and the US has heated up. Who will control space? Who will get there first? Well, we know that the Soviet Union had done a lot of firsts at the time. Laika, Gagarin, oh my God. And they also did the first walk in space for anyone else. The first extra vehicular activity in space before anyone else. All of that, though, was trumped when the US landed on the moon in 1969. So now I ask you this question. Where do we go after the moon? Well, the answer, space. One goal, which was to build a space station orbiting around the world with a very strong US presence. The concept was thought of for the concept of the space shuttle. This one fellow, Mr. Max Faget, was very instrumental in developing the spacecraft used by all of NASA's space missions from 81 up to 2011. He was important because he was very instrumental because he was part of the Mercury program, the Gemini program, the Apollo program, and of course, his baby, the space shuttle program. So he came up with the idea of using a rocket to get the orbiter into space, with it returning to Earth through gliding after being challenged from an Air Force meeting back in 1969 about a reusable spacecraft. Due to the magnitude of this behemoth project, many different jobs were contracted to different companies. For example, you had Rocketdyne, were building the shuttle engines, which were specific to the shuttle. Rockwell built the space shuttle itself under the supervision of Mr. Faget. Thiokol in Utah built the rocket boosters, and Martin Marietta, now Lockheed Martin, built the external tank, and they were located in New Orleans. The tank was very large, wider than the 747, and contained mostly liquid hydrogen and oxygen, or actually contained only liquid hydrogen and oxygen, no other liquids. So the very first flight of the space shuttle was its unofficial flight, and as many of you know, the very first shuttle was named the Enterprise, based on the fact that many Trekkies had sent in letters requesting this name. Originally, it was going to be called Glory by the government, but Trekkies got the day and they changed the name to Enterprise. In fact, at the unveiling, the original Star Trek cast was there. You have Dr. McCoy, Sulu, Spock, Lieutenant Uhura, and you have what's his name? You have everyone there. The only one who's not there is Captain Kirk. I don't know why.
He's me.
Okay. So the Enterprise was initially flown as a floor model of the shuttle. In fact, it was the only shuttle to have a needle from the nose cone. That needle was to measure certain things like airflow and whatnot. It flew, since it was the first space shuttle, it initially flew piggyback on a modified jumbo 747. Now, again, you might know that this piggybacking term was actually based on the short Mayo composite. If any of you are fans of or buffs in US history or British history, you might know what this term is. It is actually a term where you have one plane, a smaller plane, resting on top of a bigger plane. So it was originally and it's also meant for long distance travel. And this concept came up by a guy named John Kicker at NASA, who is a NASA engineer. And he devised that idea to have the shuttle sitting on top of a jumbo jet. And the testing was done for landing purposes, and it was done by pilots by 4 pilots who had by 2 pilots who had by 2 pairs of pilots, who had 5 different flights on the shuttle. The first one was done by Gordon Fullerton and Fred Hayes Jr., who, if you know about the Apollo program, Fred Hayes was in Apollo 13. So this was his second chance at flying. And there were also 2 other pilots, Joe Engel and Richard Truly. The interesting thing about these pilots, every pilot at the time had to have high-level certifications and qualifications, meaning they had to be either Air Force or Navy pilots. They needed to get those aviation wings. Okay? That is awesome. So these were the 5 flights, and these were called the ALTs, because they were the initial alternate flights. And these were just for landing and gliding to see how the space shuttle would land through gliding. And I have this as a very, very crude model. So the plan was to make it's supposed to glide down to the ground. Of course it doesn't. Now, I'll go back up here and I'll show you a picture again. This guy, Mr. Max Faget, this was his design. It was a balsa wood plane. So you can imagine he had the same issues I just did with this paper plane he had with that plane. So he needed all the help he could get, because NASA didn't really understand airplane flying as much as space flights. So they needed that help. So where are we now? Okay, here we go. Blah, blah, blah. Okay, so a total of 5 space shuttles were made. Well, 6, technically. You have the Enterprise, which was the floor model. which as soon as it was done with its testing, it was sent to a museum. Then you have Columbia, Challenger, Atlantis, Endeavour, and Discovery were all made. So these were the 5 shuttles that were used for trips to and fro from the ISS and up into orbital flight. So here we have a total of 135 missions were flown from April of 1981 up to July of 2011. This is a very interesting case. STS-1, the very first official spaceflight mission. It took place on April 12th, 1981, from Kennedy Space Center in Florida. The astronauts were John Young and Bob Crippen, both again who were highly decorated Air Force pilots. They had a very strong history with aviation. They were Air Force pilots. They were aviators, in fact. So they would teach people how to fly. So they were that good. They were the right stuff. So the mission objectives of this flight the mission objectives for this flight, they were to observe a safe launch, a safe orbit, and a safe return. It did those things, but there was a mishap. Several of the ship's tiles were stripped during the ascension phase. The tiles are very important for takeoff. The tiles were very important for takeoff and reentry because of heat shield properties. Luckily, though, they were able to make it. They had certain ideas were being tossed around at NASA at the time of using spy satellites with their cameras to examine the space shuttle to see if the damage was severe or if it could be sort of looked at on them when they landed. So luckily, they were able to make it back all right upon hearing the good news from NASA. And next one is the STS-31. This is jumping 30 missions ahead. This mission I thought is interesting because it saw the deployment of the Hubble telescope using Space Shuttle Discovery back in April 24th. And this is a long time ago now. This is history. 35 years ago, April 24th, 1990. And STS-135 was the last and final flight of the space shuttle. It departed in 2011, July 8th, and the only goal was to resupply the space station ISS up until 2012. That's pretty much it. And to let you all know, since I did not get a chance to put it here, I didn't put my references. This was my main reference. This book is titled Into the Black. This gives you all the information that you need to know about space, about the history of the space shuttle mission from conception all the way up to the final flight. Though it gives you more detail into the final flight and all the other missions. This would be a really good read.
All right, sounds perfect. Oh, there you go. I can hear myself. All right, hi. For those of you who don't know me, my name is Anaga Samaga. This is my second potpourri, and unlike the first one, it does not have endless slides of calculations, so hopefully you can stay awake for a little longer. I'm an incoming freshman at the University of Toronto for physics and astronomy, because of course. And every once in a while, I also run the youth club and the social media here at Rasmus Saga. So today I'm going to be talking about the hunt for the hypothetical planet X. And so we're just going to be going over like an introduction, the history, what evidence we have, and a conclusion. So first, introduction. So to start us off, I'm going to ask a question that to many of us has a really clear answer. So we're going to do like a vote. How many planets are in our solar system? And I'm referring to only planets and not dwarf planets. So show of hands. Was it 7? All right, 8, 9, 10. Okay, I think we got the idea. Okay, so what if I told you that potentially there was a 9th planet beyond Neptune? And no, I promise I'm not trying to beat the dead horse, that is Pluto's demotion, let's say, as rather, unfortunately, that's been classified as a dwarf planet for like longer than I've been alive. And I'm also not talking about Nibiru. Sorry. I'm also not talking about Nibiru or any other conspiracy theories either. So I'm going to be talking about a planet that's speculated to have existed for a very long time now. So let's go through a bit of a brief history of this theory. So to clear up any confusion, when I refer to planet X, the X does not refer to the Roman numeral 10, but rather a unknown variable, so like X in mathematics. So the term planet X is actually kind of retro. Our story starts with Percival Lowell. And if that name rings a bell, yes, it is the same Percival Lowell who spread the theory about the canals on Mars. In 1915, he hypothesized the existence of planet X to explain some perceived wobbles in Uranus's orbit. Turns out those wobbles were just measurement errors, a bit like, I know, calling ghost when your floorboard's creaky. But funnily enough, this initial Planet X hunt indirectly led to the discovery of Pluto in 1930. So Lowell started the hunt for a hypothesized planet, a hunt which unfortunately came to a pause after his death. Also, this is Lowell in the black and white photo. Okay. Then in 2006, much to the dismay of absolutely everyone, Pluto was demoted to become a dwarf planet, leaving a void in both our hearts and also where this theory used to be. So fast forward to 2016 to when astronomers Konstantin Batygin, the man in the middle, and Mike Brown, who is, yes, the man who killed Pluto, self-titled the Pluto Killer. But again, I promised at the start that I wouldn't, rehash that a lot. But do make note of him because he will appear a lot. So, yes, so these two astronomers at Caltech provided new evidence for a distant, unseen planet. And, because Pluto was no longer Planet 9, they did nickname their hypothesized world Planet 9. NASA doesn't really have like a position on the name, so you will hear both. You might hear me say both, and when you get like articles, you might just find both. So, interestingly, if Planet 9 does exist, it would fill a gap in our solar system's planetary lineup. So, surveys of planets around other stars so that they have super Earths, which are like bigger than Earth but smaller than Neptune. And those are really, really common, but we don't really have any in our own system. So, having Planet 9 would make us have our own super Earth in our solar system, making us a little bit more normal, I think. So, what's the evidence that this exists? So the main reason that astronomers think that Planet 9 exists comes from observing the Kuiper Belt. So as we all probably know, this is a region of icy debris beyond Neptune, which is home to my favorite Pluto, and other dwarf planets and comets. So here's the core idea. So astronomers noticed that there was an unusual clustering of orbits. Sorry, the light. Okay. Unusual clustering of orbits among several minor bodies in the Kuiper Belt. So there's 6 specific objects, such as Sedna and 2012 VP113, which had highly elongated orbits that were all surprisingly similarly oriented. It was sort of like they were all being gravitationally herded by a large object. So a recent paper published in January 2025 by Amir Siraj and his colleagues focused on this. So they looked at a significantly larger sample of distant trans-Neptunian objects, which I will be calling TNOs because try saying that 5 times fast. They looked at 51 stable and metastable objects and compared them to 11 in previous studies. So why is the stable and metastable part important? So because the gravitational influence of a distant planet takes about 1 billion years to create this clustering event, you could only expect to see it in objects that have been stable for a very, very long time. So crucially, they found statistically significant clustering at about the 3 sigma level, which means like a 99.97 or 99.7% of accuracy, I believe, in one particular orbital parameter called the longitude of the perihelion. So this means that the points where these objects come closest to the sun are all lining up in a very similar direction. So when they checked unstable TNOs, they also found no such clustering, which strongly suggests that it's a real effect and not random alignment or observational bias. It's also worth noting that while some other previous work had also considered clustering or suggested clustering in other orbital elements, such as inclination, the Siraj et al. Paper that I I'm citing for now, found statistically insignificant clustering in those other elements, such as like longitude of node and inclination, and focused exclusively on the strong signal from the longitude of the perihelion. So this indicates that the hypothesized planet's orbit might be more closely aligned with the elliptical plane than previously thought. Also, again, yeah. So the Siraj et al. Study even refines the predicted characteristics of Planet 9 based on their expanded data and simulations. So they suggest its most likely parameters are a mass of 4.4 plus or minus 1.1 Earth masses. And as it suggests, that means that the mass of this hypothesized planet would be 4.4 plus or minus 1.1 times the mass of our planet, which is significantly smaller than what it was previously thought to be before the studies. I think it was around 5. Also, they believe that it has a semi-major axis of 290 plus or minus 30 astronomical units, which is basically a measure of the perihelion to the sun of this theorized planet. And as Harry mentioned earlier, the astronomical unit is the distance between our Earth and the sun. Also, we believe it has an eccentricity of 0.29 plus or minus 0.13, with an eccentricity being basically how non-circular it is. So as we know, most perfect orbits are just a circle. The eccentricity, I believe, refers to how not circle it is. Also, it had a inclination, we believe it has an inclination of 6.8 plus or minus 5 degrees, which is basically how aligned it is with the gravitational plane. 6.8 is not a lot, so that's good. Yeah, this is significantly different, or slightly different, I guess, prediction than previously. So yeah, I think that's pretty cool. Also, recently, scientists in Taiwan named Terry Longfan and Tomotsugo Goto also claimed to have found hints of Planet 9 in old archive images from infrared telescopes, such as NASA's IRAS from the 1983 to 84, and Japan's Akari from 1983 to 2011. They found an object in one data set that wasn't in another, and vice versa, and the positions were consistent with what we think is Planet 9's possible distance. However, this evidence is considered thin with because it is 2 data points, so it's a little bit like finding like an old blurry photo of like Bigfoot from the 80s and going like, ah, yes, we found it. We do need to like fact check it more. Even Michael Brown, killer of Pluto, he put it like, I wouldn't believe anything that has just 2 data points without seeing a third, a fourth, and maybe a fifth and a sixth. I can't really argue with that. So if it is out there, how are we actually going to see it? So because it reflects so little light and it moves so slowly, it is incredibly challenging to observe. So yeah, astronomers have already been looking at it with powerful telescopes such as the Hawaii-based Keck and Sudbury telescopes, and through all-sky surveys such as the Zwicky Transient Facility and the Pan-STARRS. There's also a NASA-funded citizen science project called Backyard Worlds Planet 9, where the public can help search through images. But the real game changer, as it is for all astronomy research recently, is the Vera C. Rubin Observatory. So this is a new observatory in Chile, which is, I believe, currently undergoing testing and is expected to begin science operations in July 2025. It is July 2025. That may have changed. I don't know. Does anyone know? Perfect. That's pretty cool. All right. So it's going to be great for the search, mostly because it has the world's largest digital camera, and also it shoots a 10-year time lapse of the universe, taking a high-resolution image every 39 seconds. I was originally planning on waiting 39 seconds to show you how long or how quick that is, but for the interest of everyone's time, that's about now. Michael Brown himself said that if you were to hand me $1 billion to build a telescope to find Planet 9, I would give it back because the Vera Rubin Observatory is absolutely perfect. So, if Planet 9 is out there and falls within the moderate to brighter end of predictions, the Rubin Observatory should find it, possibly, hopefully within the next 18 months after it starts operations. Because of its wide field of view and its deep imaging capabilities, it is ideal for like detecting faint, slowly moving objects like a hypothetical distant planet. So, brings us to almost the end of my speech. The hunt for Planet 9 is probably one of modern astronomy's greatest mysteries, in my opinion at least. And while it remains theoretical, the growing mountain of evidence and more like lack of answers especially the statistically significant clustering of these stable Kuiper belt objects and those intriguing like hints from archival data kind of keeps astronomers and us on the edge of our seats as we look at the edge of the solar system. If this elusive world is finally caught, it won't just be about adding like a new number to our solar system's planetary count. It could also help us unravel why things in the Kuiper belt behave the way they do and solve kind of some of the puzzles we're dealing with. It would also fundamentally reshape how we understand the formation and evolution of our entire solar system. And as I mentioned, it might even make us a normal solar system with our very own super Earth. So keep your eyes on the news, especially after like now, July 2025, when the Vera C. Rubin Observatory will fire up its magnificent camera, because we might just be on the cusp of one of our like generation's biggest astronomy discoveries. So thank you for joining me.